Alrighty, good evening, folks. So we're going to quickly recall some of the concepts that we talked about last time. You could watch the video previous, or you could watch this video. We're going to talk about slope. We're going to continue talking about slope. Remember that slope is the expression of the steepness of a line. And remember a few things about it, right? So slopes could be positive, negative, 0, or even an undefined number. Remember that a positive slope kind of looks like that, going up left to right. Negative slope going down left to right. A 0 slope looking like a horizontal line. An undefined slope looking like a vertical line. Okay. Slopes could also be whole numbers or fractions. Now, fractions could also be decimals, but I prefer fractions because of their accuracy, right? A decimal, 0.333333333, is not as good as 1/3, right? So fractions preferred. Don't forget, of course, this is the golden information, right? How do we calculate slope? Calculate slope by doing rise over run, or just by using this formula. Delta y over delta x, so the change in y over the change in x. Calculate that. Today's lesson is mainly in two parts. One is, can you graph using a slope and a point? So easily put, we can graph these by plotting a point. So for both questions 1 and 2, you plot some points. So you can see for both questions 1 and 2, I plotted those points, 3, -1, and 2, -5. Problem here is with the slopes. Well, -3 for the first slope is kind of difficult. Like if I wanted to graph this, do I count down 3 squares? Well, that would give me a vertical line, which again, as I just said, a vertical line has an undefined slope. The trick here is noticing that -3 as a fraction is actually -3 over 1. So the rise might be -3, but the run is actually +1. So the other point that we're looking for this graph is actually there, not directly below by 3 squares, but down 3 squares and to the right by 1. A moment to think about question number 2, and the next point will appear in just a second. Wow, isn't that neat? I plotted more than one point. Because remember, if we're talking about a line has the same slope all the way through, a straight line at least. So I counted up 1 over 2, up 1 over 2, because the rise is +1 here, and the run is +2, up 1 over 2. All that remains is connecting these dots and creating some lines. I will say, however, that my line on the right is a little bit more accurate. But why is it more accurate? Because I plotted more points, right? I was able to line it up a little bit easier with my ruler. My graph on the left isn't really all that accurate. I only used 2 reference points. You can clean that up by plotting some more points by counting down 3 and right 1. I'm going to leave it for now, okay? So just know for a fact that the more points that you plot, the more accurate your line should be, okay? Question 3, if I wanted to state some more coordinates or points that lie on these, well, I can state this one, of course. The coordinates of that point are 4 and -4. If I wanted another point, I could count down 3 and over 1. That gives me 5 and -7. Okay, I could do the same thing over here. Let's get the coordinates of that point. 4 and -4. Okay, what a coincidence. What about this one? That'd be 6 and -3. I guarantee if you calculated the green slope on the left by using delta y over delta x, you would actually get a slope of -3. I also guarantee that if you were to calculate the slope of the blue 2 points, you should get a slope of 1 over 2. Because you started with the premise that the slope was -3 and 1/2 respectively, so you should wind up getting the same slope in the end anyway. Let's talk about another example dealing with some terminology, collinear. Now, collinear means exactly what it looks like it means. Co, meaning together, linear, meaning of a line, together in a line. Okay, so 3 or more points are said to be collinear if they lie on the same straight line. Use slopes to determine if points A, B, and C are collinear. So all you have to do is basically calculate the slope of AB and calculate the slope of BC. I'm going to do that, and it's just going to pop up in a sec. And there's your answers, okay? So you see on the left where I've calculated the slope of AB, I've used some neat notations. It's important that you understand that M represents the slope of the line. We use that letter to represent slope. Why? Actually, nobody knows, okay? We just use a lowercase m to represent the slope. I use the subscript AB to talk about the slope of AB. So the line segment that would be made by AB has a slope of AB. We calculate it by using y2 minus y1 over x2 minus x1. And we calculate it as negative 6 over negative 4. That actually simplifies to be 3/2. So again, on the right side, the red, we're calculating the slope of BC. Okay? So we calculate the slope of BC by doing y2 minus y1 over x2 minus x1. We get, again, negative 6 over negative 4, which simplifies to 3/2. And we can finally make the conclusion, of course, that they are collinear. They're collinear again because they all have the same slope. If they had different slopes, they wouldn't be in the same line together. Question B deals with 3 points again, and we start with the assumption that they are collinear. Right? The question says that they are collinear. But we don't know what this k value is, right? We have absolutely no idea what k is. Well, we do know what the slope should be, right? We know that the slope between D and E, we could calculate that. So go ahead, pause the video, calculate it. I'm going to pause my video and calculate. So you can see here that I've calculated the slope of DE, simply because I can. We did 1 minus negative 1, that actually means 1 plus 1, and that gets us 2 over negative 1. 2 over negative 1 simplifies to be negative 2. Now there's something special, and I've circled it in blue. There's something special about this slope. This is actually the same slope as the slope of EF. Why? Because we were told that they are collinear. So if they are collinear, the slope of EF should be negative 2 as well. You can also come up with a math expression, or an algebraic expression, for the slope of EF. Right? It's k minus 1 over 7 minus 1. Where did I get that from? Y minus 2 minus y2 minus y1 over x2 minus x1, right? We're just calculating the slope between E and F, right? Well, we can actually solve this equation. So I'm going to solve this equation. You pause your video, you solve it, and join me in a second. All right, take a look at my solution. The slope of EF is equal to negative 2. It's also equal to k minus 1 over 7 minus 1. I could collect the 7 minus 1 as 6, right? So that's what I've written here in my second step. The next step is basically to multiply both sides of this equation by 6. So you remember from the last unit, we can do this. We can multiply both sides of the equation by a number. It stays an equation. If we multiply by 6, that gets rid of this over 6 business. It gets rid of that fraction, which is kind of nice. It changes the left side to negative 12, however. So then, negative 12 equals k minus 1. Hopefully you see that that minus 1, we could add 1 to both sides, and that leaves us with negative 11 equals k. So that's that problem solved. So why don't we take a look at some similar examples where we know the slope of the line, but we don't know some piece of information from the points, or the ordered pairs that we use to create them. Again, it comes back to creating an equation. Okay, so we know that the slope of the line is negative 2. In this case, we know that that should equal y2 minus y1. We know y2 is 9, but we know y1 is negative 1. So minus minus 1, oops. Right, that'll eventually give us a plus. x2 minus x1 is 4 minus x. We don't know what x is. We can simplify the top of this equation, right? 9 minus minus 1 is 9 plus 1. Negative 2 equals 10 over 4 minus x. Now that's a pretty difficult equation to solve if you really, really don't know what you're doing. But think about it this way, right? In the last example, we had something over 6, and we multiplied by 6 to get rid of it. But what if we multiply both sides of this equation by 4 minus x? How to think about that? Multiply by 4 minus x. That 4 minus x and that 4 minus x will cancel each other out. But in order to keep this in equation, we've got to multiply this side by 4 minus x. Well, let's clean that up a little bit. 2 multiplied by 4 minus x should equal 10. What would we do to solve here? Well, you can divide both sides of this equation by negative 2, or you could distribute the negative 2. Me personally, I'm a fan of distribution. So negative 2 times 4 is negative 8. Negative 2 times negative x is actually positive 2x, and that equals 10 on the other side of the equation. Bring the negative 8 to the other side, you get 18. Divide both sides by 2, and you get x equals 9. There you go. That's what x should equal. Now, you can check your answer, obviously, by substituting 9 back into that original ordered pair and calculating the slope, right? So if you took the 9 that's here, and you substituted it in right there, and you calculated the slope between those 2 points, that slope had better be -2, because if it's not, you got the wrong answer. Well, try B. So pause your video and try B, and press play when you're ready to see the solution. All right, so here's my solution. I start off with the point that slope is 3/4. So 3/4 should be equal to y2 minus y1 over x2 minus x1. So again, I set that up as an equation. I collect my like terms on the denominator of the right side. So 4 minus 2 is actually 2. And then I do something really tricky. So we talked about in our last unit about solving equations. We can solve an equation by coming up with a common denominator. Because once we get that common denominator, we multiply both sides by that denominator, and poof, there goes the denominator. It's no longer there. So we do that trickily by sort of changing the denominator on the right side of the equation. We do that, change it to 4. But in order to change it to 4, we got to multiply the numerator by 2. So I put the 2 outside of brackets. You could distribute mentally if you wanted to. Multiply both sides by 4, and you cancel off all those 4s. So you're actually left with, basically, if you follow my arrow up to here, you get 3 equals to bracket 1 minus y bracket. Distribute that 2, bring that 2 over to the other side, divide by -2, and you get 1 over -2 equals y. Now remember, we kind of prefer to have negatives either in the middle or with the numerator. So you clean that up a little bit, and you get this as your final answer. -1/2 equals y. Well, what does that mean? Well, that means that, y was a half, was halfway in between 0 and -1. -1/2. Okay, so remember, you can actually have values within your ordered pairs that are decimals or fractions as well. That's fair game. That exists. Okay, so I hope you've sort of seen a little bit of playing around with when you know the slope, you can figure out another coordinate from a point, and also that you're comfortable with graphing today. But we're getting close to around that 12-13 minute mark, so I don't want to go too long here. We'll talk about some more word problems, some more difficult, challenging things tomorrow. Hope you have a good night.